funky. Okay, everybody ready for a talk about hacking web applications? All right. Hello, I'm Acidus. I've spoken here the last couple of years, and a lot of you are real familiar to me. And so hopefully this will be up to par with my normal stuff. I think it will. If I told Decius about what I was doing, and his first words to me were, "Holy shit, you can do that?" And the next thing were, "You've got to present that at PhreakNIC." So I think you'll enjoy this. Yeah, that bastard. He's dropping off Cisco gear, which I think means making it with his Nashville woman. All right, here we go. Yeah, the mom. Oh, God. Okay, here we go. Actually, let me go back one. I'm going to be talking about Layer 7, basically ways to extend applications, web applications in interesting ways. Quick overview, we're going to talk about what web applications are, how do they work, traditional versus the current buzzword, which is AJAX. We're going to talk about writing web applications on top of existing web applications, using open published APIs like Google Maps, and then also without their knowledge or consent, because that's always just fun. And lions, tigers, and demos, oh my. All right, definitions, at least my fucked up perception of what these things are called. User agent is an application for accessing a web resource. A web application is a complex service accessible with just a user agent, i.e. just a web browser. I'm standing in the way? You want me to go more here? Ah, y'all can see that? Okay. So a web application is a complex service accessible with just a user agent. Service is something that dynamically generates HTML in response to a user input. And a website is basically just a collection of static HTML and services which generate dynamic HTML. Okay, traditional web apps. You know, we all have seen these things: search engine, commerce sites, shipment tracking, mapping sites, webmail, all circa 1995. All really cool, but old. But these are the cool new web applications. Gmail, Maps, Suggest, Flickr. Are you seeing a trend? It's the same stuff that's 10 years old, only we have a new cool way of doing this app. I also would like to point out Writely. If you guys haven't ever played with this, it is, I think it's writely.com or .org or something like that. It's actually a word processor written entirely in JavaScript and AJAX and fun stuff like that. It's a great way to collaborate online. Like, two people can be editing a document at the same time, and changes are instantaneous between the two users. So you can like fight for control of words and stuff, which is a lot of fun. Flickr and SmugMug, both photo sharing sites. So what's new about these? Why are those so much better than these web apps we've had for a really long amount of time? Well, this is what a traditional web application looks like. You have a browser, you have some type of JavaScript logic layer, which normally validates your input, possibly some type of local variable cache, your ubiquitous internet cloud, goes to a web server. The server has some type of logic on it, you know, PHP, Perl, whatever, to act on the input and generate something, and normally is referencing some type of database. And you also have some back-end processes that actually populate this database. Great example for this is like a search engine. When you're doing a search engine, you're not actually sending a little crawler out on the internet to find this stuff for you. They always have crawlers running, populating a database, and their website is hitting off that database. So, new web applications. The only thing different are these two lines. AJAX, to take the mystery out of it, is a way for JavaScript to make not quite arbitrary, but just basically HTTP connections back to the server. So, when you were using Hotmail differs from, say, Gmail, and when you click on Hotmail and you go to your address book and then you click a message, each time you're doing a server refresh. Each time you're actually going back, hitting the server, your page blinks. From a more, layer 3, layer 4 point of view, what's happening is each time you're doing that, you're initiating a TCP connection, three-way handshake. You have the issues of TCP slow start. So doing postbacks to servers is relatively slow. AJAX, however, allows JavaScript to be making these things, not necessarily on behalf of buttons you're pushing, but just for shits and giggles anyway. When you're using Google Maps and you start like dragging all around, going crazy, JavaScript is actually preloading 4 or 5 screens on all sides of you, grabbing all the images, because it knows you're most likely going to go there. So you're basically, instead of, not using your upstream or downstream at all, spike. This is a more traditional thing, not doing anything, spike, and when you do a refresh. But with JavaScript, it's pretty much a constant, always grabbing stuff, trying to anticipate what you next need. As a whole, AJAX applications perform much faster because another great thing about this is the TCP connection between your browser and the server never closes. So you don't have to worry about slow start with TCP connections. You don't have to worry about reestablishing state. You can pipeline. You have persistent connections. It's really fast. But conceptually, it's the same. So the components of a web app, I already started to talk about them. You've got some type of browser interface, which is rendering HTML, XML, HTML plus cascading style sheets, other fun stuff. You have some type of client-side scripting or logical layer. This is, you're filling out your form, you click submit, but JavaScript hops in the way and goes, this isn't a valid, zip code, something like that. Again, if we go back to this model right here, oh man, this thing's slow when it comes to images. The whole point of this is back when you didn't have AJAX applications, but you had, going the wrong way again, when you had this, instead of making a post all the way to here and then find out, oh crap, it's the wrong zip code, they'd attempt to do it here. So it's a lot faster, because this is incredibly costly using traditional means. So you've got some type of validation layer, it gives you dancing gerbils, whatever. You've got a web server, you've got your script generating pages, which are Apache, custom, whatever. You've got a SQL database and like your backend. So just to give you a concept of what I'm talking about here, and I'm sorry if I'm insulting your intelligence, but it's really important you understand this before I move on. A great example for client-side stuff, you have HTML forms, which can gather different types of input, get, post, put is for actually uploading files. And the way you submit this data is by actually doing a refresh with the server. You've got JavaScript, which can process things locally, such as, oh, I built a little fun calculator. You download the HTML, you start filling in forms, you click submit, but you're not actually doing a post back. JavaScript goes, oh, let me take form A, multiply it by form B, here's your answer. I made a really simple JavaScript calculator. So you can process it locally or actually do a refresh back to the main page. AJAX, and also when you do new image, and so, who here has actually written JavaScript code? Okay, just a couple. You know how you go to a web page and you'll see ads that rotate and things like that? One of the things they're doing is actually using JavaScript. There's an object, because it's kind of object-oriented, but not really. There's a way you can say, hey, go get this image for me. It's at this URL. Get it and display it. Both the image object and AJAX allow you to make what I call connect-backs. You can just arbitrarily connect to the server and pull down information without user intervention. You have some more proprietary technologies like Flash, Java, ActiveX. I mean, the specs for Flash and Java are relatively open, but the way that Flash or Java or ActiveX actually does a connect back to the server, not necessarily HTTP. I can write a Java applet that makes a socket connection back to the server, and I can use this weird, crazy Java object serialization stuff to transmit information back and forth. So as a whole, standards are your friends, and we're going to be talking about this stuff. So, server side. On refresh, basically we're processing input, performing some types of calculations inside a script, possibly making database queries and updates, returning back a page. On connect back, we're literally just directly fetching and returning some object. It's normally just a simple HTTP GET with a 200 OK response. And, proprietary is different. We don't really know, but we don't really care. Okay, so just to beat this horse a little more, prime example of this, to break it down, airline flight tracker, you've got an HTML form, you've got some type of JavaScript which checks to say, wait a minute, did they enter a valid flight number? If it's more than 4 digits, or it's got some letters, this is not a Delta flight number. They got a web server, they've got a PHP script with MySQL, they're accessing MySQL, and then they also have some back-end process that's importing comma-separated values, maybe a flight information, maybe a reservation information, and they have some type of updater. So just to break that down. All right. Wow, I'm going really quick, too, so we'll see if we can't get this back on schedule or have more fun with the demos. I'm sorry, I should have said this from the beginning. I tend to talk really quick, and so if you have questions, I'm going to be like this and not paying attention, so just shout them out. Don't raise your hand, because I won't see it. I have no problem with people interrupting me, unless it's a stupid question, and then we will all chastise you. Yes, there are, and that was a stupid statement. Okay, so extending web applications. This is fun stuff. Essentially, we're using resources and services of a web application by a different website or external program. So, I've got a really fun example would be, you can go to You can submit a zip code to like weather.com and get like a map of your forecast back. I could write a plug-in to Myth TV that like does that thing for me. It's like, go get my weather, and it does like, it uses wget or something, and it grabs this picture and then displays it. You know, I don't have access to that information. This other service has access to that information. This other service doesn't really give me that information in a way I can directly display it, so I have to get exactly what I want, pull it out, and display it the way I want. This is not simply data mining or scraping an existing site and then using a local cached copy. This is actually using their dynamic content. And the reason that's important is so few sites are static HTML. In fact, if it's static HTML, why would you want to be interfacing to it anyway? Because it's not changing. And if it's dynamic, grabbing a local copy of it isn't going to help you because it's dynamic. So you really have to find out how to interface to an existing service. Okay. Some else collected the data. Oh, wow. I wrote some of these on my drive up here, so it doesn't necessarily make sense. That's supposed to say someone else collected the data, and we are just reprocessing it. We can add quality to the service, though, because we can do correlation between multiple data sources. I could go grab information from IMDb, and I could go grab information from, like, the Weather Channel and find out if it's raining on Kevin Bacon. Because it might be. Ultimately, more powerful than the original application. That's the whole point of extending web apps is you found something cool, maybe their interface is real kludgy and you hate it, like weather.com or so many other websites, and you are adding value. Okay, so extending web applications, it's all about standards. We're going to basically be focusing on HTTP-based client-server communications, you know, dealing with HTTP as a transport medium. We're going to be transporting things like XML. I don't know why I have that there, but RSS is XML basically over HTTP with some type of structure, and AJAX is a way for applications to make these arbitrary connections. In fact, the big use of AJAX is pulling down XML files and reading them. In fact, and parsing their information. In fact, like when you actually create a AJAX connection, the call is like XML HTTP request equals, and you give it like the path, the HTTP method you want it to use, and the port, something like that, to actually go make the call for you. Interestingly enough, who here is like a little HTTP ninja and does lots of like web stuff? Wow, like no one. So you can do crazy stuff with web applications. You guys know like open proxies, right? If you're browsing the internet, you can go through open proxies, and so it doesn't trace back to your IP address. When you make a connection to a proxy, if you're doing SSL or encrypted traffic, because the proxy can't be able to decrypt what you're talking about, you basically ask the proxy, go make a connection to this guy on my behalf, and then blindly relay traffic between the two of us because it's encrypted. The first part of that statement should freak you guys out. Hey, computer, who is anonymous and probably shouldn't be on the internet anyway, and someone misconfigured you, go make a connection to this guy. Trust me, it's okay. And just blindly relay everything that happens. You can port scan through proxies. It's actually an interesting thing I'm working on, and you probably will see a paper pretty soon, but you can port scan through proxies. I don't know why no one does this, but you can do it in fast, and you can do it, you know, across multiple things. So some poor guy sitting there looking at his logs and going, oh my God, I'm getting port scanned from, you know, China and Korea and Iran and everything simultaneously, because I can say server port, and then I look at the error that comes back. I'm like, oh, couldn't connect, or site didn't exist. So interesting stuff. Anyway, complex Flash, ActiveX, Java sockets are out. You know, and they're really not very good anyway. Because if they were very good, Google Maps would be using, you know, Flash or, you know, something else, and not AJAX and JavaScript. It's not open as it should be. I mean, it gives you a little more power. You can make it an arbitrary raw, you know, socket, TCP socket, as opposed to an HTTP connection. But there's nothing you can't send over an HTTP connection that you could send over a socket. There really isn't a difference. So legitimate extensions to existing web applications typically involve APIs. Google and Yahoo publish the API to use their Google Maps for free. Did everyone browse around the PhreakNIC website and see Dolomite's little restaurant guide thing? You guys noticed it was using Google Maps. The way, if you actually did a view source and saw what he was doing, there was a JavaScript block. And it has right at the front, basically, he makes requests to Google using a particular key that they gave him. And if you don't have that key, they won't let you connect. And they give you this key for free. You have to register, but they give it to you for free, and it's free for non-commercial use. I think Yahoo has a similar license. So it doesn't cost any money, really, to interface to these existing services. And often that's fun. Non-sanctioned extensions of web apps, a little more fun. A little harder, but a lot more fun, because, just one day, somebody's sitting there reading, Slashdot, and finds out, oh my God, somebody wrote something that's running on top of my web application, and I didn't even know about it. Have y'all seen ChicagoCrimes.org? We're going to talk about that. That's something that's taking police data, which was a web service that was being offered for free from the Chicago Police Department, and was taking Google Maps and overlaying the two. That's exactly what I'm talking about, being able to correlate multiple web services into making a much more powerful application. So here's an example, housingmaps.com. If you guys haven't been there, this is really cool. This is relatively close to where I live in Atlanta, and you can just type in Atlanta price ranges, show me stuff, and then here's that fun little Google teardrop thing, and you click on it, it pops up, and you see pictures. This is actually using Google Maps and Craigslist. It's pulling images and descriptions from Craigslist, and it's mapping it on top. And most major cities are supported. You can just go to housingmaps.com. It's really cool. So that is a officially sanctioned, not officially sanctioned, but let's say legitimate extension, because we are very quickly going to be talking about unlegitimate applications. Yeah, illegitimate. Do I look like an English major? All right, so ChicagoCrime.org. This is just freaky. It's like, financial identity. Wow, I didn't even see that. Financial identity theft occurred at October 12th at 4:25 at a residence. I guess somebody was dumpster diving. 6600 block, South Fairbanks. It's so funny because you could browse by crime, be like, I wonder what the arson circuit is like today. And here you got a nice little map of Chicago, and what this tells you is it's great to live here and it sucks to live here. So what would be awesome is if you've got ChicagoCrime.org, which is using criminal data and Google Maps to be a combined service. You've got Housing Maps, which is using Craigslist and Google's Maps to be a combined service. But you really need a third tier that's combining crime maps and apartment finding. So you can be like, find me an apartment where murders don't happen. So that thing's fun. I like that a lot. So non-sanctioned extensions. You don't have an API because you're not supposed to be doing what you're doing. Not necessarily not supposed to be doing, but nobody ever anticipated you doing it. So I'm sure that has stopped no one in this room where someone's like, well, there aren't instructions on how to do this, but you can figure it out. Especially if you use Linux. That's basically all you've got. There aren't any instructions, but figure it out. As we found out earlier with the fucking S video. So directly connecting to resources and parsing them. That's basically what you're going to have to be doing. You're going to be making an HTTP connection. You're going to be doing some type of GET. You're going to be getting some amount of information back. You're going to be parsing it and going, I got this thing from weather.com, but I really only care about this image, and you pull it out. Hopefully you cannot directly connect to their SQL database. First of all, if you could, I would not recommend doing it because they probably didn't mean for you to do that. At least making a request to a web application, getting a response back and parsing it, you could argue what you're really writing is a user agent. I'm writing an equivalent of a web browser, but instead of being a web browser, it grabs maps or it grabs crime statistics. And I'm accessing this information the same way other users access this information, i.e. making GET requests, getting responses back. So don't try to directly connect to their database, even if they were stupid enough to let you. Legality. Well, read the terms of service. Luckily, the site I'm going to talk about didn't really have a terms of service, so we're all good there. The big thing, though, is look for the clause about retransmission of content. You'll go to, like, dictionary.com, or obviously I need dictionary.com since I'm saying unlegitimate. So you can't republish information from dictionary.com without their expressed, I think it's written permission. So you can't even, like, fake an email from them. Yes?
More likely you're causing someone else's computer to make mistakes with retransmission.
Yeah, I mean, I guess that's true. It's a gray line, and I actually didn't put a slide in here. We're going to talk about it at the end. There are some alternatives to writing non-sanctioned extensions. Hold on one second. If legally they're not allowing you to do it, a lot of times the data that person has, you can get that data elsewhere for free. The census, like, first of all, the government, holy God. I mean, disorganized, bloated, whatever, but they have so much fucking data. And they have, like, you can go download the census data and get, like, hi, I want a program that makes fake IDs based on the most common names and addresses and all sorts of fun stuff. Or, there's a Perl module that does, like, GPS, like, number. Yeah, it does, like, numbers to latitude, longitude. And what they did is they mined the U.S. Geological Survey. And they've got aerial maps, and it's like 1.2 terabytes uncompressed. It's insane. So you can get the data. Somebody have a question, and I said no? Yeah. Now, this is what I'm going to talk about. You can write because of JavaScript and because of, well, Ajax doesn't let you make arbitrary connections to any website you want, because that would be a huge security vulnerability. But incidentally, I found a way around that. That will be a black hat talk. We're hoping. I'm forming that up and submitting that. But I basically busted the entire security model of the DOM. And you can access any site you want and just screw with it. No, they might be letting me go once the criminal charges are filed, but that remains to be seen. So you were asking me, how does this operate? Basically, you could use JavaScript. You could do other stuff to basically make your web browser be like a customized agent, make these requests for you. I'm basically going to be talking about writing Perl modules, writing Perl programs, Java programs, whatever your flavor is, to actually make HTTP connections for you, get information back, parse it, and present it to you. So is that clear? You can set up a refer. You can lie. Are you doing the web application talk? Oh, okay. Damn, I wanted to see that. If you were lying? First of all, the first thing you need to know about web application security is never trust anything you get from the client, because they can lie about everything. And lying on your refer, you guys know what an HTTP refer is. When you click a link, it makes an HTTP request, most likely an HTTP GET request, which says, hey, give me this. And the server goes, okay, let me see, path valid. Oh, okay, I looked this up. Oh, it's an image. Ah, here you go. And one of the things that's sent when you say, hey, give me that, in addition to your user agent, what browser are you using, and not your IP address explicitly, though they find that out from the lower levels. They find out certain things like what languages you accept. So if you request a URL that's in multiple languages, or a resource that's in multiple languages, they'll give you the correct one. You send something that says refer. Where am I coming from? So if a lot of times news sites, like New York Times used to do this a while ago, if someone, Rattle's always deep linking things on meme streams. He's posting, you guys should be using meme streams, by the way. He'll post a link to a story on New York Times, and it will be like a, 150 character long URL. If you click that story, you send a GET request that says, hey, give me this. The server looks at that and goes, well, you want this really deep resource, but the referrer field says you're not coming from anywhere, meaning you're deep linking into the site. And it will go, no, you have to come to this resource through like our front page. And the server will preemptively go, no, redirect, go to the front page, I'm not giving you this resource. So that's what a referrer is, and you can totally lie. In fact, for NewYorkTimes.com, or New York Times, if you don't want to register, if you make requests using wget, and you say, my referrer is Google.com, New York Times is like, ooh, Google, Google News, we want people who are using Google News to read our story. And so if you fake your referrer and say, I'm coming from Google, they'll give you the stories without any story you want. In fact, even the archives that you have to pay for. You should do that. It's fun stuff. Huh? Certainly. Huh? It used to get you into the archives. I'm going to have to poke around. I actually was talking to Decius. I wanted to make a button on meme streams, which was get this New York Times story, where meme stream would do it. How am I doing on time? Does anybody know? If everyone doesn't know, then nobody can kick me out. All right, so here's a great example of a non-sanctioned email extension. Y'all heard about the Gmail file system? Runs on top of Gmail. It's awesome. It's an actual mountable file system, which is really cool because you can do reads and writes. Sends email /clusters /attachments to and from Gmail. Now, technically, it's using SMTP instead of HTTP, but you access Gmail using HTTP. So the same way you would compose an email and say enter, you would be using an HTTP post or a put versus a mail from and a receipt to. I mean, it's a different protocol, but they are so similar. You could implement the Gmail file system actually making raw connections to the website as opposed to making raw connections to their their mail server. but it's the same concept. It's an awesome hack. The guy had no API at all, and he hasn't been sued yet. Oh, well, no, but it's using POP and SMTP, because it's sending and receiving. Yeah, you could use any combination of them. You guys following me? I'm not... Okay. I don't want to insult your intelligence, but I don't want you to go, damn, I didn't understand a dang thing he said. This is cool stuff. All right, case study. Who here has heard of TinyURL? Yeah, TinyURL. It's good stuff. It's a service that allows users to submit a very long URL and assign it a 1 to 5 character unique ID. I'm probably going to call it a hash. It's not really a hash. They're not taking the data you're having and hashing it. There are no collisions in TinyURL. They just give you an ID. You can use, so basically, when a user goes to this address, like in this is the hash, it uses a 302 redirect. The server goes, oh, go to this page. And that's how it makes your web server, when you go to this address, appear at, say, CNN.com. Now, an interesting thing is that if the URL you entered already exists in TinyURL, the first thing it does a lookup and say, do I have this URL already? Because everybody's going to like TinyURL CNN.com, which is kind of odd because CNN.com is actually a shorter URL than you'll get doing TinyURL / and hash. Interestingly enough, they used to assign these hashes progressively. So if you go to tinyurl.com/dick, you get Dick Cheney, which I thought was funny as hell. And if you try some other very vulgar 4- and 3-letter words, you get all sorts of other fun sites where somebody was predicting when these things would come up and was making, submissions. And they quickly changed it to randomly generated. So this, it's a small, neat, and fast. Now, this thing gets 200 million hits a day or a month. That's insane. Good God, I can't even fathom that. 18 million URLs are in their database. That's pretty cool. In fact, they end up getting, if it was like they started at full popularity and went over I think they've been around since 2001, it's something like 9,000 new URLs are added a day if it were linear. By now, it's probably, like 15,000 a day. Okay, so let's do a little more research. URLs are submitted as either an HTTP GET or an HTTP POST. Do you guys know the difference between the two? A GET. Okay, have you ever gone to Google and you do a search and then the next page you go to, it's like google.com/bunch of gibberish. That's an HTTP GET. You're passing the input, your query, to the server inside the URL. Am I blocking you guys again? Yes. Oh, well, what happens is that if you do an HTTP GET, the URL, the actual URL you request is, foo.asp, question mark, for Google it's Q equals search query, semicolon, or, ampersand, and then like, lang equals en, and, crap like that. That's actually the URL you grab. When you do a post, you take all that information that's at the end of the URL and actually put it in the body of your request. So you make a request to, say, foo.asp, and you pass as parameters actually inside the body, not in the header, those variables. That's the difference. The other difference is that I cannot give you, if it's a post, I cannot give you a link to the Google results for a search term. Because by clicking that link, you're doing a GET request just for that link, and there's no way for me to kind of say, hey, do a post with this information. I have to say, hey, go to this URL, which has it embedded. Does that make sense? This is important. We'll touch on why it's important in a second. So you submit a URL. It gets stored in a very simple database. If the URL already exists, the ID that's already been issued is given. And it uses standard 302 redirects to move the browser to the submitted site. So I go to tinyurl.com/24, and it goes 302 redirects, go to CNN.com. So, this is kind of interesting. We can write into this database, and we can read from this database. What else can we stick in there? Can it not be a URL? So I used an HTML form, and I basically just made I made a little localhost page that submitted to TinyURL, and I submitted about 200 characters of English text. Sure enough, it worked, which, makes sense. I'm not really looking for HTTP, I guess, and so I used an HTML form, and I submitted 300 characters of base 64 encoded data, so, random-looking gibberish stuff. And again, it worked. So the lesson that we learned here is do lots of verification on any data you receive from the user. This is how you write a web app. You don't just go, oh, yeah, I'm supposed to be accepting URLs, but I don't really care if it has HTTP:// or a .com or anything in it. Just give me anything. I'll take it. So that's a little odd. So again, doing a little more, I wrote a quick Java app to actually make an HTTP request for me, and I uploaded 4K of base 64 encoded data. And it worked. I was like, So I uploaded the complete works of Lewis Carroll. And it works. So you guys are hackers. I'm sure you've done this. I mean, Telnet is basically what you can use Telnet and like read your mail. You can use Telnet and use web browsing. You just Telnet to the web server, and you say, hey, do a get with this URL, HTTP, specify. And you press enter, and it's as if this is what your browser sends. In addition, it would send refer, host, my user agent, some other junk. But this hash right here in tinyURL is 220K of base 64 encoded data. So when you do this, you get back a header that says 302 redirect. The new location is 220K of base 64 encoded data. Do you have any idea what IE and Firefox do when they get 220K of data as the URL? Holy God. Old versions just core dump. Firefox just locks, and IE's just like, not responding. Control-Alt-Delete, end task. So the lesson learned here is do not allow arbitrary amounts of user-defined information to be uploaded into your database. Do not allow arbitrary amounts of user-encoded data to be uploaded into your database. Virgil. Which, incidentally, we're getting to, but as near as I can tell, if you read the RFCs, there is no definition of how long a URL can be. Probably because they decided, URL could we have no idea what other types of services will be run on these. When they came up with the concept of URLs, they had Gopher and all these shit we don't even hear anymore, and now we have all these other concepts. In fact, there's a URL, the protocol, HTTP, FTP, whatever. There's a protocol that's actually data : / you can specify data and make it render, which is very interesting. So, I guess I could let this slide. Yes, you pass a mind pipe. I want to go quick. Dolomite, you're not here to boot me, are you?
No, I'm not here to boot you.
Or boo me? You're here to praise. Okay.
I'm here to say thank you for speaking and releasing your new
My new code?
your new code.
They haven't seen it yet, but they're gonna like it. So what does all this mean? This means I can write any amount of information into a database with an HTTP command. This means I can read any information out of it with an HTTP redirect by looking at the location header. I can implement a write once, read many, anonymous, and totally persistent file system on top of tinyURL. So let's think about this. What are the considerations? We need to spread a file. We don't want to have, a URL that is, 5 megs in length. So I want to take this URL, break it into clusters, and each cluster is a different ID. So each one is a different entry in the database. Break it up into 4 clusters. Very much like a file system works. I need to base 64 encode the data. Because I'm storing it in a database, I have no idea if they take, only the 7 bits of ASCII, if they take 8 bits. I don't know what type of character encoding they're using. If I base 64 it, which is what they do for email, I know it won't get molested. So I know it'll survive the internet. But base 64 in data also increases the size of your data by 33%. So to not be a dick, I really should compress the data before I base 64 encode it to make it as absolute small as possible, so I don't totally, own their database with, gigs and gigs of porn. I've already shoved the entire works of Lewis Carroll in there. Don't want to put the entire works of Ron Jeremy in one URL either. So this is interesting, I should implement encryption. Because if somebody, like me, starts to just randomly guess hashes, I might find a cluster that's in the middle of your file. And it'll be plain text. And if it's a text file, I'll just get this little snidbit of, like a dirty email or something. And so encryption is what we want to do so people can't stumble upon it or brute force plain text. Also, the fun thing about this is, right, we don't want tinyURL to know we're doing this, right? They get 18 million. They got 18 million things in that database. They get 200 million hits a day. They got 18,000 new hashes being added a day. If we keep this small and we don't make it, I want to make it so they can't just, do a select statement and some stuff on their SQL database and find these clusters. So you've got to kind of think about how to protect that. So, tiny disk. This allows saving and retrieving files from tinyURL. The saving procedure produces a it's funny, you can laugh, it's cool. I laughed my ass off. You know, Jill will tell me I just burst out laughing, going, oh my god, I can't believe they let me do that. Alright, so the saving procedure of sticking something in tinyURL has to produce a type of metafile. And this metafile is basically instructions on how to reconstruct it. I mean, if you think like, you know, a file system, you've got the FAT, which is basically, look, if you want this file, here are the clusters where that is. We can't store the FAT inside this tinyURL file system. We actually have to store it externally. And then when you want a file, you just say, look, here's my little ticket. It tells me what the name was, what it was encrypted with, and where it's stored. And so you can go and retrieve it. So, yes, you supply the metafile to the reading portion of the program, and it just goes and grabs it for you. And also, so the first thing I do is I zlib compress it, so using the deflate algorithm, because it's free and it's implemented in Perl and Java and all sorts of things. I randomly generate a 128-bit key, because I'm storing the key in the metafile. It doesn't have to be something I can remember. It's in the metafile. So I might as well make it really freaking hard for people to crack. So you use a secure random number generator and just come up with 128 bits. I base 64 the resulting thing. I then divide that into clusters, whatever size I want. Now, I'm using 4K clusters right now. When we talk a little later about how to make this covert so they can't, you know, stop it, we'll talk about how to change the cluster size. So this is an example of a metafile. I don't know how many of you can read that, but it's a rather basic-looking file. It's got a version, tells you the file name of the file that's stored, tells you its original size. I used a checksum algorithm of CRC32. Here's the checksum. I used deflate to compress it again, so it's all upgradable. You could, you know, implement checksum as MD5 instead. Here's the encryption key that I used. Here's a base 64 representation of those 128-bit encryption key. Here's the cluster list. This is 20 clusters, and this is Alice in Wonderland from Project Gutenberg, by the way. This is 20 clusters, and here's just a list of the hashes where those clusters are. So, let's do a demo. All right. So, here's what we got. So, first thing, I'm in... let me do this. So, I'm going to talk about this later, but I wasn't a dick. While I was developing this, I wasn't uploading crap to tinyURL. I actually implemented a version of tinyURL in my local machine. It's 2 PHP files. They're basically identical to the PHP files that tinyURL uses, in the same way of detecting a signature when something was created and a signature when something failed. And I have a MySQL database running locally on this. Basically because I messed up a lot when developing this. They would have had like hundreds of megs of just junk in their database had I not done this. So I will do a describe just for you guys to see. It's incredibly simple. Describe URLs. Thanks. Okay, so basically, I've got a hash, which is a variable length, or it's a varchar, 5 things length. It's a primary key. It's got a URL, which is a long blob and has no defined length. Now, the funny thing is, when I was like creating a MySQL database to be like tinyURL, I had to actually be stupid. I had to be like, oh, I should put some type of length on this. I'm like, wait, no, they don't do that. Like, I don't know how they didn't do this on purpose, because it is so hard to design a database that just lets random people throw shit in it. Yes. Oh, actually, I'm not. I'm going to do it off the local, because we could dump it in tinyURL, but I'll just do it locally. So here's what we got right here. I'll just do a select. They use a SQL data. Well, I don't know. They could use any type of database, but they could be using a local DB file. In fact, that might be why they get some pretty good speed. Select star from URL. And here you see right now there's nothing in the database. I just purged it. So what I'm going to do is I'm going to go over here. So first of all, just for fun, I've got, this is the Project Gutenberg of Alice in Wonderland. Alice in Wonderland, blah, blah, blah. So I'm going to take this file and I'm going to stick it inside tinyURL. Oh, I'm not VI. All right, so I wrote this in Java. I apologize. Java-jar. Not Tommy. Unlike most CS nerds, I cannot type well one-handed. All right. write, so I'm going to go ahead and write the file alice.txt into alice.txt, and then the final parameter you have to give is the meta file. I'm still modifying this code slightly so it'll dump the meta file to standard out if you don't do it. But we're going to stick the meta file alice.tinydist file. Okay, off it fires. Ooh, that's not cool. Hold on. Oh, tinydist.jar. Okay. So it says, I'll move this up so you can see it. It loads the jar. So it says, reading Alice, generating encryption key, compressing using deflate, encrypting using AES 128 bits, base64 encoding, uploading to tinyURL, and this is actually the key it used. Let me go ahead and move that up a little higher so you all can see it. So there's all the relevant fun stuff. Reading, generating, compressing, encrypting, base64 encoding, uploading. Really very simple. We can see the URL that was created, or we can see that meta file, Alice, and it's going to look a lot like the example I had before. You know, here's some clusters, here's a key, blah, 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 and there are all the clusters, 20 clusters. Okay. If I come over here, I can't do select star because each register thing will be 4K. So I'm just going to do select the hash. Sorry. I told you I'm not an English major. All right, so sure enough, we see here are a bunch of hashes, and all of them are 4K, except for the last one, and there are 20 of them. So now, I'm going to come out here. Whoops. I'm going to do a tiny disk. I'm going to do read. I'm going to specify the meta file. As we see, found key, retrieving clusters, base64 decoding, decompressing, or decrypting, decompressing, alice.txt successfully retrieved. And sure enough, we see there's Alice. Yeah, Alice doesn't live here anymore. She lives in tinyURL. And there we go. We pulled the whole thing, we uploaded it to the database, and we yanked it back down, and they are none the wiser. So, fun stuff. Yeah. All right. So is this? I did click that. All right. Here we go. So, do I talk about it? Oh, covert tiny disk. So this is interesting. So really, metafiles are the keys to the kingdom, right? Because metafiles tell you what clusters are the files stored in. They also tell you the encryption key. They tell you everything you need to reconstruct the information. If I were the admin of tinyURL and I found out this thing went, I would start doing Google searches for these metafiles because they would tell me what clusters had files stored in them, and then I'd just delete a couple of those clusters. No one could retrieve the files. So tinydisk actually right now can create encrypted metafiles, and they look exactly like PGP, public keys. Actually generates, says PGP, public key block, blah, 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 base64 encoded representation of the metafile, including checksum at the end. There. And so I can just be like, email my friend Tom, be like, hey, Tom, go download the file. PGP key attached to my signature. That's not unusual, but the PGP key is the metafile. And so what is tinyURL going to do? Are they going to grab every single public key on the internet and then try to check it? Oh, by the way, it's encrypted with a 128-bit random key. Good luck with that. And find out whether it's a metafile or actually a public key. They can't possibly. I mean, this screws them. So they have other ways of tracking this down because they have control of the database. And they can start saying, okay, well, we need to find clusters that are 4K in length. Well, I'm sorry? Ah, yes. Well, clusters can be prefixed with sites that have base64 URL parameters. Everybody look at the URL for Google Groups or Yahoo or Amazon when you're really freaking far into like the checkout process or something. It's freaking enormous. Everyone here heard of Overture? It's an advertising data mining collection. You'll always see cookies from 207.net or something like that. Their URLs are like over a K long, and it's all gibberish. So I'll just start sticking those into your database, and you won't be able to tell the difference between the, using tinyURL to bookmark a product and base64 encoded data that represents a file. I mean, granted, I have to spread the stuff out over more URLs because I only have a length of, say, 512 is the size of my URL plus the prefix. But still, I mean, Not my database. I don't really care how many. And incidentally, if I'm spreading a 200K file over 20 hashes, or I'm spreading it over, 1,000 hashes, there's a marginal, disk hit for them, but really it's not that bad. It doesn't matter whether it's in 1, 20, or 1,000. It's storing 200K regardless. Of course, the problem is that your meta file gets large, which is why using and eventually your meta file gets so large. Imagine having 1 byte in each cluster. Your meta file would be larger than the file you're retrieving. That's exactly what I'm talking about doing, yeah. Yeah, that's what I'm doing, is I'm saying when I submit it to tinyURL, stick a fake prefix on the front of it, so they can't just run through it and find it. Like a linked list, like saying the next cluster is here. That would be interesting. That would be kind of cool. It would reduce the size of the meta file. The funny thing is that I wanted to post this to Slashdot because I'm sure they'll love it, and I've got this available for you all to download and have fun. But I want to distribute it by writing a proxy, a web app, and you say I want to download the file, and that web app goes ahead, contacts tinyURL, and downloads it. I store tiny disk inside a tiny disk. Go ahead, Strick.
If they have 18 million URLs, and say the average URL is 64 bytes long, that would fit in RAM on a lot of our machines. It probably fits in RAM on their machines until you do this.
Probably. I'm sure they're going to notice a whole lot of disk thrashing. But the thing is that, I actually did, for another thing entirely, I was out at TourCon and giving a presentation on phishing and identity theft, and Rattle actually put me on the thing of, hey, do they actually use tinyURL to hide, cross-site scripting parameters? And so I wrote a little program, and I harvested about half their, not half, it was like 2 or 3% of their database. I think I got about 400,000 things. And I started going, okay, well, what's the average length? The interesting thing is I think somebody else might be onto this, because I found 2 URLs that were 64K long. And it was and it was just this gibberish bullcrap data. And so it might have been encrypted. I don't know. Maybe somebody's already done this. There might be like this leak scene of people who are storing things inside tinyURL. And, come Monday, if it's on Slashdot, they're going to be like, fuck, the golden age is gone. So I know I'm going a long time. I want to try to finish this stuff up. But so I can prefix it. There's a lot of stuff I could do to hide the covert nature of this. Yes? Yeah, I mean, it's HTTP. Run it through a network of proxies. Right. So the way of hiding access to information by one group of people inside a large community is a very interesting topic, because you're right. I mean, there are ways they could stop this. They could start going, well, don't let a user or a single IP address make more than 15 tiny URLs a day. Or when one IP address makes 200 in the span of 5 seconds, delete all those because it's a file. I mean, yeah, there's stuff they can do, in which case I slow it out, I put it through proxies, and then you start having the utility versus, whatever. I mean, you can always go do the Gmail file system, but the thing with the Gmail file system is you have to give someone login credentials. This is really, if you can imagine it, it's a networked CD-ROM. I burn it, I stick a file on it, and then you guys can read it all you want. In fact, the demo I wanted to do, but I was having some issues here, was create a CRAM-FS file system. Mount just in a file, mount it on a loopback device, and upload it. And then automatically have files to basically say, like, mount this disk inside tinyURL. And what it actually does is pulls the thing down, mounts it, so you can have like a directory structure inside. All sorts of fun stuff. I also looked at the ISO file system because it has redundancy and things like that. Because that's really what this is. I'm creating something, sticking it in. I can never edit it once it's in there. And anybody can read it. And how do you hide those access patterns is kind of a different problem. Yes? Well, that's the thing. Rule number 1, check to see if it's valid information. But I stick the prefix on it. How can they tell a Google Groups dot, blah, 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 junk, what? Well, yeah, they can ping it, but they're going to get a 200 OK from Google going, I don't know what, oh, this message is not in our servers. The thing is tinyURL has been around since 2001. They have so many broken links inside them, it's ridiculous. So let's say they would have to write, do what you're talking about. They would have to write filters, like really freaking complex regexes, for each site I use, so that when somebody posts something that's to Google Groups, they would have to go ping Google Groups, comment down, run it through the regex to see if that's Google Groups coming back going, I don't know what this is. And then they'd have to do that for Amazon, and for Yahoo, and for MapQuest, and for I can find more sites than they can possibly write regexes. They're going to get a nice, pretty, they're getting that pretty URL. Certainly, no, it redirects to a URL, but what I'm saying is it redirects them to Google Groups. They're going to have to check, hey, is this page that got returned by Google Groups? Does this page say, I don't know what this is? Not 404 response. It's going to be a 200 OK. We can talk about this later, but that is not an issue. Yeah, it's a pretty error message on a pretty page. And exactly. Wow, apparently I had my things a little odd. No, covert. OK, here we go. So nano URL. Implementation of tiny URL. It's 2 PHP pages in a MySQL database. The MySQL database I already showed you. It's a hash and a ginormous thing. And again, I cannot insist the number of times I created the database, but created it wrong because it wasn't open enough. I don't know how they created this thing without, explicitly like drinking heavily or just going, what the hell? Honestly, what I think it was is they said, we're not going to limit the size people can upload inside the database, but we'll have a soft limit in software. Because right now we might want to limit it to 2K, but in 3 years there might be some awesome freaking internet service, VoIP : / junk. And so they said we can always move the soft limit, but they never implemented a soft limit. So it allowed me to develop TinyDisk without polluting TinyURL's database. You can download this from mostsignificantbit.org. Not yet. It's going up. I was typing this stuff up in the car. I'll put it up there tonight. And I'm going to submit this to Slashdot. Hopefully they'll pick it up. And oh my God, TinyURL is going to get like 50 gigs dumped in it in like a day. Decius really, he's like, do you really want to do this? I mean, it's not like it's a company. It's just some dude. And the funny thing is I know everything about this dude. Because if you look at the very, very early hashes for TinyURL, remember they used to be assigned sequentially. So if you go to tinyurl.com/1, 1 doesn't work, but like A, B, G, some of these single letter, double letter ones, they all point to this site about unicycles. Unicyclist.com. Which, incidentally, if you do a who is and you check, the same person owns tinyurl.com. It owns unicyclist.com. And so he was testing it. And I kind of feel bad for this guy, but I mean, he's got Google ads. He gets 200 million hits a night, or a month. He's not hurting. So TinyDisk, again, this is just a JavaScript command line, or it's a Java command line program. Very simple to use. You guys saw it, TinyDisk read, TinyDisk write. That easy. GPL for your enjoyment. And you can also specify with the config file whether you want to use a nano URL database that's somewhere, define host and port where the website's running, or actually use TinyURL. So, somebody could set up a anonymous file drop and be like, look, I'm offering the TinyURL/TinyDisk service for anybody who wants it. Please upload. So you can download that from msblabs.org, but not quite yet tonight. Please, and go get it, play with it, have fun. Please download nano URL and play with it on your local box. But it's a lot of fun. So again, kind of nice little side tangent of a proof of concept, but tips for writing non-sanctioned extensions to web apps. You want to make things as generic as possible because your API is subject to change. The way TinyDisk does what it does is it makes a post. Remember when I was talking about HTTP gets versus posts? Gets, they pass all the information inside the URL. Posts, they pass it in the body. Well, the thing is while there isn't really a limit defined for URLs, like IIS, Apache, IE, Firefox, they kind of impose random arbitrary limits. IE is like, nah, if it's over 2K, screw that. I'm not defending it, which is probably why it locks like hell when it gets to 220K. Also the signatures that are returned back by TinyURL. When I submit this in, I was talking about posts. I had to use posts instead of HTTP gets because I had to, move, say, 4K of information in, if that's my cluster size. And so I just do a post, I submit it. I get an HTTP response, which is a 200 OK, and the 200 OK says, yes, this URL was added, here is the hash. And so I actually have a regex defined in a config file which says, look, this is the signature of what a, yeah, that's good, we added it to the database looks like. And also, here is the string that you want to pull out to find where the hash is, because you need to stick that in the meta file. So making things as generic as possible is very good, because your API is going to change as soon as they catch on to things, and you've got to be smarter and work around it. Don't try to make any money off your extension, even with Google Ads, because they could argue theft of service. I mean, if you're accessing something and they're not making money off it, and they don't even have Google Ads, and you don't have Google Ads, they can't really say you're stealing their service and offering it to others because they weren't making money off it. They can't argue there was any loss of money or loss of revenue. I actually was in Knoxville yesterday listening to the, among other people, the district, what was it, the circuit court. It's like the United States, like this big fat DA guy, federal DA guy. He was talking about stuff. Incidentally, you were doing the web app talk. I was talking with FBI agents yesterday, and I said, you know, this is kind of funny because I'm presenting in a suit, and in 24 hours I'm going to be presenting in a black T-shirt in front of other people with black T-shirts. And they're like, oh, yeah, you're talking about PhreakNIC, right? That's this weekend. I'm like, yeah. And they're like, oh, no, we know this guy was doing something about web application security talk. So it's kind of interesting. But feds are cool. I enjoyed my chat with them. Yes?
One thing to keep in mind is if they are charging for their service and you're not charging for yours, they probably could still argue with theft of service when they start defining the window.
Yeah, no, that's what I'm saying. If they're charging money and you're not, you're stealing from them and offering it for free, which is why it's great, because tinyURL has no terms of service to speak of whatsoever. So also throttle your app so you're reducing the impact on the original site. I put a cap. It's in the config file, but you can change it. I put a cap on the size of a file you can upload into tinyURL or nano URL as a meg. You don't want to abuse these people. I mean, you can change that and abuse them if you want, but, you know, do try to be nice. Remember that they had something cool and you found a way to make it better, but you still need to respect that they did come up with something cool. Contacting the authors. It's interesting. I actually have not contacted the author of tinyURL. I have a feeling I will be speaking with him in the next couple of days. Yeah, and, you know, but, you know, the interesting thing is you can sometimes help them add functionality. You know, a lot of times people won't even think, oh, I could have done this. That would have been cool. Oh, damn. You know, you're right. Crime, apartment listings, genius. You know, step 1, apartment and crime. You know, step 2, nothing. Step 3, profit. You know, there's always good ideas. So contacting authors can't hurt, unless they sue you. Anybody have any questions? What, where you can download it? Yeah. msblabs.org. And I will put that up tonight so you all can have fun with it. I will. And see, my web server, it's like a FTP. They don't have anything else. And there's no way in hell I'm going to FTP from a wireless network at a HackerCon. So I'm going to, you know, SSH somewhere, upload this stuff. I want to tweak the config file and make some of the error messages a little more friendly so JavaScript doesn't just like segfault on you if you don't supply the right parameters, things like that. But it'll be up tonight. I encourage you to use it, play with it, tell your friends about it, and submit it to Slashdot if you want, because I'm going to submit it to Slashdot too, and hopefully they will pick it up and we'll have fun. Yeah, 3 or 4 times. Yeah, knowing Slashdot, you know, dupe. You know, the funny thing is, I know I'm still going, and Skydog's here to, like, you know, beat my ass and get me off the stage, but this is really funny. So, 3 more hours? Okay. I could give my fishing talk from TourCon, which the feds really like. You guys might like that. I'll do that. So I work at a web security company, which is weird because I didn't do any web security things a couple of months ago. And in our break room, we just got a new bulletin board. You know, it's right next to the, you know, the kitchen and whatever. We got this new bulletin board. I kid you not. I went in, workers are installing the bulletin board. You know, went to lunch, came back, went to get a Coke. The only thing on the bulletin board was a piece of white paper, thumbnailed on, and all it said was first post. 10 minutes later, there's another thing on it. Below it, slightly to the right, that says +1 funny. So thank you guys very much for being attentive and answering asking very intelligent questions. I'm Acidus. You can go to msblabs.org. You can also email me or at acidus@yak, because I try not to hit strict server too hard. But feel free to email me if you have any questions, comments. Yes. Yeah. It's actually on. There will be a page uploaded on MSB Labs. On the front page, it'll say Tiny Disk is here, Nano URL is here. It'll probably be msblabs.org/tinydisk, but it will be up tonight. So, anybody have any other questions? Yes. I'm sorry. That would be cool. I've really thought about trying to build a distribution system for metafiles and like a way to search metafiles. Well, it's interesting because you have to remember that the metafile is kind of the Achilles heel. And if tinyurl wanted to be a dick, they could take all the metafiles and delete everything. And so, until I gauge the reception, I don't really want to, spend a lot of time into building this, bit torrent of metafiles. Yes. Mm-hmm. You certainly could use that. Because it's 301, it's 302 redirects, which is where the server is actually going, oh, you want that? Hold on. Pulls out from the database, oh, here's the URL, 302 redirect to this URL. So it's not like that URL, it's not like tinyurl.com/hash ever gets cached by anything. Because crawlers, even Coral Cache would be like, oh, it's not a 200 OK, it's a server directive, I'm just going to ignore this. So I don't know. But if anyone wants to come up here right now with a thumb drive and get Tiny Disk, they're more than free to grab that. But I'm going to let this go because I know there's some stuff going on tonight. But again, thanks a lot. I appreciate it.